Okay, we're going to be talking about equivalent linear equations. Okay? Equivalent linear equations is when we're talking about lines that have the same graph. Okay? Essentially, they are the same equation. So, I want you guys to take a look at this first equation here. Do you guys see any relationship between the first one and the second one?
Yeah.
What is it?
The second one is half. The first one is double the.
Second one, okay, or vice versa. So the relationship between the two is that this one is double that, and the one below is, you could say, times a half or divided by 2, either one. Okay? So these are essentially the same equation. What we mean by that is I can take one of them, okay, and we'll take the first one, x plus 8 minus 6y equals 0. And what we're going to do, thank you, is we're going to divide each of the terms in this equation by 2. Okay? So essentially the idea is whatever I do to one side, I have to do every term on the other side. So because we divided 0 by 2, we divide all those terms by 2. So x divided by 2 can also be represented as a half x. 8 divided by 2 is 4, and 6y, or negative 6y divided by 2 is negative 3y. 0 divided by 2 is still 0. So we have created the second equation by just dividing the first one by 2. Relatively simple concept. Okay? These would be equal equations. Okay? It's the exact same thing if we graph it. So, we're going to start to talk about systems. And a system is when we have two lines on a graph. Okay? So what we'll do is we're going to scroll down a little. And in our systems, yesterday we talked about solving systems by substitution. Okay? We're going to talk about the 3 different solutions you can get for types of systems. Okay? There's going to be one point of intersection. So one answer could be 1 point of intersection. And that would essentially just be 2 lines that cross at a specific spot. Okay? We'll call it a POI, point of intersection. A second solution could be no points of intersection. Does anyone have an idea what that might look like? Where we have 2 lines that have no points of intersection?
One line may be on top of the other, or...
Okay, well one of these is technically on top of the other, it's above it.
No, I mean like one can go to the positive and the other one goes to the negative.
Well, if one goes positive, one goes negative, for sure they're going to cross.
They're parallel.
Parallel, that's what we're looking at. We're looking at 2 lines that are parallel to each other. That's the only way we end up with no solutions. Okay? These lines go forever and are parallel to each other. Okay? We'll end up with no points of intersection on those 2. How do we know if lines are parallel? If we have it in y equals mx plus b form, how do we know?
They have the same slope.
Same slope. Good. So, important note. Lines with the same slope.
Same slope as what?
Same slope as each other.
Oh, because they're 2 equations?
Yeah. Okay. So for instance, we'll make up a quick example here. They can have different, and as you guys can see, different y-intercepts. So I'm going to quickly make up slopes for each of these. I'm going to say that the first line, we'll call this guy line 1, his equation is y is equal to 2x plus 2. And we'll say line 2 is y is equal to 2x minus 3. Okay? The equations are different. If you guys notice, our y-intercepts, one's at positive 2, one's at negative 3. Negative 3, positive 2. But the slopes are the same. So since the slopes are the exact same, these lines can never cross each other. It'll never work. Okay, so we don't have a system. We don't have a point of intersection. And finally, our last option is called infinite points of intersection. Infinite points of intersection. All right? Make this one a little bigger. And we'll have one graph like this. What type of line would have infinite points of intersection to this line? Infinite points. Circle will only cross it twice, maybe once, but max twice. What did we talk about at the beginning? Same equation. If it's the exact same line on top of the other line, that means at every single point it's touching the other line. Okay? So, for instance, the way this can be represented is we'll give this, again, this looks like it's y equals x minus 1. We'll call that equation 1. Well, equation 2 is y equals 2y equals 2x minus 2. Notice anything about these two equations? One's just double the other, or it could be quadruple, triple, doesn't really matter. It's actually the exact same equation. Okay? Because when I go to isolate y in this equation, which means I'd have to divide each side by 2, y becomes x minus 1. So it's the exact same equation. So when I would go to graph that, I get the exact same line right on top of it. So these are infinite points of intersection. In other words, lines that are the exact same. These are our three options when you have two lines on a graph. Okay? You have one point of intersection, no points of intersection, or infinite points of intersection.